We had already talked about how to use Descartes' rule of signs to, describe the zeros. Yeah.
Hypothetically, like on a test report, how many of these would you think?
One, maybe, yeah. Like one rule of signs, one finding zeros, and so on. Okay, now the directions, right, that will prompt you to use Descartes' rule of signs. It'll say, describe. The word is describe the possible real zeros. When it says describe, you have to figure out by Descartes' rule of signs this chart. All right, so let's do one now. Here I had split it up into steps. Now I'm not going to do that. We're just going to, do it like from step 1 to 6 and do the whole thing. So the first thing we're going to do is look at the coefficients and see where the coefficients alternate signs. So here I have a negative followed by a positive. That's one case. And then I have a positive followed by a negative. That's 2. And then negative followed by a positive, that's 3. That is awesome. Yeah. So the number of positive, I start with 3, and then I have to keep subtracting 2. So minus 2, so it's 3 or 1. Now, for the number of negatives, I need to find f of negative x. So yesterday, we kind of came up with a little bit, with a conjecture. We said if a term has an even exponent, right, power of 2, 4, 6, 8, nothing happens, nothing changes. You just copy it down. Negative 11 x to the 4. But if a term has an odd exponent, x, because that's the rule. Like, so now the next step is you have to find f of negative x and see the alternating sign. So if one has an odd exponent, x to the power of 1, 3, 5, the sign for that will change from plus to minus and vice versa. So positive 20 will become negative 20x cubed. The next one, it has an even exponent, doesn't change, so plus 3x squared. Next one is x to the 1. That's an odd exponent. You change negative to positive, x. Whoops. I'll talk about it one more time in a minute. And then the 18, that's a constant. It remains unchanged. So one last time. When you're finding f of negative x, you scan your function, your original function. Only the ones that have odd exponents will switch signs. The rest will be the same. Okay? So Tati, just look for the odd exponents and change their sign. Odd exponent, change the sign. Odd exponent, change the sign. The rest will be the same. The reason is, yesterday we were substituting negative x. And then negative to the power of an even number doesn't happen. Yeah. So now we're going to do the same thing. How many times do you have negative followed by positive and vice versa? One time here, and that's it. So number of negative is 1. Is it possible to subtract 2 from that and not get a negative? No, there is not enough to subtract 2, so we're done. Now I need to make the chart. To make the chart, we need 3 columns. Positive, negative, imaginary. All right? Now, again, I have a purple team and a red team. Each player on the purple team has to play against each player on the red team. How many possible games are there going to be? 3 plays against the 1, 1 plays against the 1, and that's it, right? So we pair the purple 3 with the red 1, the purple 1 with the red 1. And that's it. Okay? That's it. Huh? Yeah. The next column is imaginary. Please, when you're doing the pairings, the purples were the number for the positives. Make sure you put those numbers under the plus column. These were the negatives. Make sure you put the red numbers under the negative column. Now, what was the degree of this function? 4. So each row has to add up to 4. In the first case, 3 plus 1 is already 4. I don't need to put anything else to compensate. In the second column, 1 plus 1 is 2. I need an additional 2 to compensate. Again, you see that this column can only be 0 or even. Okay, can never be odd. Okay, that's Descartes' rule of signs. We can never tell from the very beginning how many rows this is going to have. So here we had 2 rows, up here we had 4 rows. We can never tell until we do the number of positive and the number of negatives. Okay, what has this told us? This has told us that this function, right, can have at most one negative 0, right? So if you determine that, let's say negative 3 is a 0 of this function, can negative 5 also be a 0 of this function? It cannot. It only has one negative value for a 0. Okay, that's what it tells you. Okay. So let's talk about complex zeros. These theorems just say that, remember how we said if there is a degree of 4, it has at most 4 zeros? Those zeros can either be real numbers or imaginary numbers. That's all that fundamental theorem says. Okay, moving on. Factorization theorem, what does that say? Suppose you have a function like this, and it crosses the x-axis at -1, at 4, and 7. So the zeros are -1, 4, and 7. That means each of those gives us a term in the function. So if I have x equals -1 as a 0, it means x plus 1 is a factor for this function. If x equals 4 is a 0, x minus 4 is a factor. If x equals 7 is a 0, x minus 7 is a factor. Okay? All right. Now, we've got this new function now. X to the 5. Look at how nasty that looks, right? We're going to factor this and write it as a product. Okay, write as a product of factors. All that means is factor. That's all that means. Okay. We're going to start with P over Q. So let's do P over Q. Now, this coefficient here is a 1, right? To get my Q's. When that's a 1, what do I know about P over Q? It's just the same as the P's, right? It's just the same as the P's. So P over Q is going to be the factors of what number? 24. So let's do plus or minus, and let's see what are factors of 24. 1 is always a factor. 2 is a factor of 24. Is 3? 4? 5? 6 is? Okay, and then look, once you get to a point where like 4 times 6, right, it's next to each other, 4 times 6 is 24. The next one now, it's like 3 times what? 8. And then, 2 times what? 24. And then 1 times what? Yeah, I mean 12 and 24. You see that? So once you get to the point where two consecutive ones are factors of each other, like 4 times 6, and then you go outside, 3 times 8, 2 times 12, 1 times 24. It's magical. Math is so symmetric, like there is just, okay. So now, how many numbers in this list? 16, right? Because it's plus and minus. It's all the pluses and all the minuses. So potentially then, we would have to do like 10, 11 synthetic divisions before we find one that works, right? So we're going to eliminate the synthetic divisions though, okay? And what we're going to do is we're going to graph this one. So go ahead and take out your calculators and graph them. Of these three x-intercepts, we decided, which one did we decide to use? -3? Let's use -3. So what we're going to do is synthetic division with the -3. 1, 1, -13, -23, -14, -24. 1 comes down, -3, -2, 6, -7, 21, -2, +6, -8, +24, 0. Okay, now, hang on. Now, from this, right, I get a term x plus 3. So it's x minus that point, minus is plus 3. From this, I get the depressed polynomial, which is x squared. I'm sorry, not x squared. X to the 4 minus 2x cubed minus 7x squared minus 2x minus 8. Now, the point is, this is factored. The blue one needs to be factored some more. Now, this is still a pretty complicated function that we cannot factor by hand. That means what you have to do now is another synthetic division just for the blue part. So now, theoretically, we would keep doing synthetic divisions again until we get one that gives us a 0. But what we are going to do is go back to our calculator screen, right? This is the important part now. You go back to the calculator screen, and now you select an additional point where it crosses the x-axis. Remember how we had 3 choices here? We used up one of them. We used up -3. Now we have 2 more that we can choose from. And again, you can choose whichever one you want. Which one do you guys want to do? -2. This is the first time everybody's choosing the negative ones. Okay, so we're going to do -2 just on the blue part. 1, -2, -7, -2, -8. 1, -2, -4. 8. 1, -2, -4. +8, 0. Okay, I got a 0. Now, what do I have? I have the x plus 3 from before. I have the x plus 2 from here. And then in addition, I have this guy. Now, what's the exponent? X to the what? 3 minus 4x squared plus x minus 4. Now, I need to factor the green. Okay. If you can factor, you factor. Because if you can't factor, you have to do synthetic division again with another point from the screen. Okay. Now, look at this function. I have a cubic term. The degree is 3. It's a cubic term. Okay, that's one criterion. Another one is, how many terms does this have? 4. If you have a cubic function with 4 terms, it is a good candidate to factor by grouping. Okay, so my go-to is always factor by grouping. Again, it has to have 4 terms and a degree of 3. So I'm going to copy this over here. And that's the green. Interestingly, it would still give you a different cubic with 4 terms that you could still factor. Yeah, it'll all work out the same. So here's how we factor this. Let's copy these down. Here, I split this down the middle. Now, from the left, what can I factor out? X squared, and I get x minus 4. And the right is plus another x minus 4. Okay, now, I have a common term, right? X minus 4, x minus 4. The first parenthesis, x minus 4, has an x squared in front. What does the second one have in front? A 1. Put the 1 there just for this purpose because it kind of helps later. So now here's what we do to factor. The common term is x minus 4, right? Write it over here. Now, what have I got left? X squared plus 1. That goes here. And now we have factored. If you find that you're a little rusty on factoring by grouping, come to bonus and I'm more than happy to go over it with you, right? So this is one that we learn in Algebra 1 and then in Intermediate or Algebra 2. So I want to go, so if you want to go over it again, let's do it at bonus or in the Math Center. Yeah. Once you write the common term, you then sort of like collect whatever else was missing. Whatever else you didn't touch yet, the x squared plus 1, you just write it here in the second parenthesis. Okay, so the common term was x minus 4. I wrote that down. And then what do I have left? I have an x squared plus a 1. Okay, so I write that here. Well, so that depends on the... Yeah, that depends on the function that you have. So basically now this is factored. That's what we needed to do, and we factored it. Next it says to list all the zeros. Well, this is the easy part because we get what we just factored and set it equal to 0. From here I get x is negative 3. X is negative 2. X is 4. Hey, did we already know that when we graphed? We did, right? So we have lots of ways to be able to check our work. However, this, I have to do a little bit more work when I set it equal to 0. I subtract 1. And now I need to take a square root. So x is plus or minus the square root of negative 1, which is I. Okay, so now how many answers do I have? 1, 2, 3, 4, 5. This is the imaginary number. How many imaginary numbers came out of this? 2. So this is how you get imaginary numbers. It's always plus or minus. This is why in this column, the imaginary numbers must have pairs, right? It has to be an even number here because it's always plus or minus. So a few more things here. This was supposed to have 5 zeros, and sure enough, we found the 5 zeros. If you go on the graph, it looks like it only has 3 zeros. The reason is 3 of the zeros are real numbers. The other 2 are imaginary, so they don't show up on the graph. Okay? So even if you do have your calculator, you can never get all 5 zeros for these functions. Okay. Well, I mean, if it has imaginary ones. Okay. Now what we're going to do is go backwards. I'm going to give you the zeros, and I'm going to say, find the function. I know, oh my God. Believe it or not, a lot simpler than this. Okay? I know. Neither did I until I learned it, right? This is why we're here. But isn't it cool that okay, so did you ever think in your life that you would be able to factor something like this and find all the zeros?
I was just thinking that, like, I never
right?
thought we would do math.
And look, we did it. We did it.
Are the zeros just where it crosses the x-axis?
Right, but what if you didn't have your calculator? Could you still do this? You could, because it would just take long, because you could just try synthetic division with each of these until you found ones that gave you zeros and just continued it. So you can totally, if you're ever stuck on a desert island with no calculator, you could sit there and graph and factor functions until, the rest of your life. And, what a fulfilling life that is, right? Okay, yes.
I just don't understand why you did it.
So, it says write a polynomial function, which means we need to come up with f of x of least degree with real coefficients in standard form. I'll talk about all that later. That has the given zeros. What are the zeros? It's this, right? Those are the zeros. So, the first thing we do is we say, okay, we need a function f of x. Each of those zeros gives us a factor. The x minus 3 gives me x plus 3. The 4 gives me x minus 4. Right? We can do that. Just make sure, though, you take opposite sign. Why do we do this? Because if you have this and you need to find the zeros, what is it? It's x equals negative 3 and x equals positive 4, right? So we could go back and forth. Now what we need to do is distribute, which you call FOIL. I don't like the term. Anyways, that's a me thing. So first terms gives us x squared. Outer terms, negative 4x. Inner terms, 3x. Last terms, negative 12. And finally, x squared minus x minus 12. Okay. Now, that was a very simple case. Let's take it up a notch. Now I'm given negative 1 is a 0, 2 is a 0, and I is a 0. So here's the question for you. Can I ever exist? Not I, but that I. I can exist on my own. But can that I ever exist on its own? No. What else does it have to be with? It has to have a partner. So when you have an I, you have to add in a negative I. Okay? Okay, you have to add that in. Right? Okay, now, f of x. So look here for a minute. How many zeros did this problem have? 2, and the degree was 2. This has 4 zeros, so the degree is going to be 4. Okay, let's do it. X plus 1, x minus 2, x plus I, x minus I. Did I do that quickly? Are we okay with that one?
Yeah, you just write x to the form.
You can't. Give me a minute. Give me a minute, and then we're gonna get there. Let's do this in parts. I like to divide and conquer. First, we're gonna do this. Just FOIL, like we did before. I'm gonna let you do that, and then we're gonna regroup. So I'm gonna give you, a few seconds to do that. On your mark, get set, go. What did we get for that one? X squared minus x minus 2. Now, this next one, right? I'm going to do it in red. Some of you might recognize what the final answer is immediately. Okay? I'm just going to do it out here slowly one time, and then we'll come up with some conjectures. Okay? Again, I'm going to do first terms, outer terms, negative ix, inner terms, positive ix, last terms, negative I squared. Now, I have x squared. What happens to negative ix and positive ix? They go away. Here I have negative I squared, right? What is that now? Okay, x squared minus I squared is negative 1. So together, this is x squared plus 1. So this in here, it's x squared plus 1. Can you do it with, quickly like a shortcut? You can. Here's how you do it. When it's i's, imaginary numbers, you square the first term. You square the coefficient of the I, which is a 1. And you always put a plus in the middle. It's different from when it's a real number. Okay? Only for imaginary. It has to be a plus. Okay? Square the x. Square the coefficient of the I, which is a 1. In the middle, put a plus. Okay? Okay. Now, I still have to distribute this. So I'm going to give everybody an x squared. So this is going to be x to the 4 minus x cubed minus 2x squared. And then I'm going to give everybody a 1. This is x to the 4 minus x cubed minus x squared minus x minus 2. 4 terms. In the instructions, it said, with real coefficients, which means, okay, like there are no imaginary numbers in here. In standard form, right, that's what it said in the instructions. In standard form, it means your function has to go in decreasing order of exponents. That's standard form. Decreasing order of exponents. Okay, let's do one more. Last one. Yeah. Let's do this one. F of x is equal to, all right, I have my zeros, root 3, negative root 3, 2i, and what else do I need to add? Negative 2i. So I have x minus root 3, x plus root 3, x minus 2i, x plus 2i. Okay, let's just look at what we have here. Here I have x minus something, x plus something. Are these real or imaginary? Real. This one, x minus something, x plus something. Are those real or imaginary? Imaginary. Okay, so first it's to recognize, right, that it's x minus something, x plus something in both cases. Then to recognize one is real, one is imaginary. Now, we're going to do both of these using our handy dandy shortcut. So, for the first one, it's when you have x minus something, x plus something, you square the first one, x squared. You square the second one, what do you get? Root 3 squared is 3. These were real, right? When they're real, you put a negative in the middle. Okay? Yep. Now the next one. You square the first one. You square the coefficient of the second one. 2 squared, 4. Because these came from imaginaries, you put a plus in the middle. Okay? Right? After this, we're going to basically FOIL again. So, f of x equals, the first terms are x to the 4. The last terms are the outer terms are 4x squared. Inner terms, negative 3x squared. Last terms, negative 12. And you have to see if there is anything you can combine, which it looks like there is. And here we go. Cool? All right. Let's do the multiplying with the i's over with the, the whole process. So I have x minus 2i, x plus 2i, right? Let's see why we get a plus 4. Okay. First terms, x squared. Outer terms, plus 2ix. Inner terms, negative 2ix. Last terms, you get what? Negative 4i squared. So, x squared, what happens to the green and the blue? Go away. Now I have negative 4i squared, right? So, okay, we got a negative. So how come it switches to positive? Well, let's see. This is x squared minus 4 times, what's I squared? Negative 1. I squared is negative 1. So now, this is x squared plus 4. Okay? All right? And there is that.
So basically, it's always going to be a positive because
Yeah. Yeah.
minus.
Yep. So that's why initially I say, okay, x minus something, x plus something, but they're real, so you get a negative. X minus something, x plus something, but they're imaginary, so you get a positive. The rest is the same process, but the sign inside will be different.
The ones with the imaginaries and the real will always be this rule.
Always. As long as it's x minus something, x plus something, like the same thing, right? It's always this shortcut. All right. So this homework is what will be due on next class. And remember, next class you're turning in homework. We've started, right? So it has to be ready to turn in.
There's no